recording. And then I'm gonna screen share. Okie dokie. So I'm basically gonna go through modules 7 and 8 with y'all. I know that module 8, we're gonna, if you guys need help with that acid-base stuff, I'll go over that. But for the most part, I'm not trying to go over a lot of like the sample problems that he has. I'm gonna go over like the actual examples or the actual kind of questions he could ask on the exam. So I'm just gonna go over like some of the concepts um, from each of the modules, and then yeah, that's kind of the schedule for the last couple of SIs. Okay, so thermodynamics. So first things first, you need to know what a spontaneous process is, right? Spontaneous is when delta G is negative, okay? Spontaneity is different from entropy, okay? I know there's a couple of people that like are a little confused. Delta S refers to entropy, which is like chaos, and delta G is the spontaneity, right? So if you have a positive delta G, it's non-spontaneous, and negative delta G is spontaneous. So this is entropy. Entropy is like the randomness. Okay, you don't really need to memorize any of this stuff with the cards or anything. It's so funny. Like he always talked about these cards, but I never seen him actually hold a card. He's never brought a card deck to class, and it's kind of I don't know. I don't believe that he actually knows card tricks. But um, okay, so this idea of positional entropy, like you don't need to really think about it in terms of this stuff, but this is what's really important. As a gas, like molecules can move around. So like think of it like the container, right? This is an Erlenmeyer flask, and this volume is this volume, right? And gas molecules, they can contain the whole volume and move all around the gas container, right? Whereas liquid, they are confined to the volume of the liquid, right? So they can't move that far within the volume. And then likewise, crystalline solids don't move at all, right? So there is an increase in entropy because the position of the atoms increases, like they can move in different places. So gaseous molecules have more entropy than liquids and more entropy than solids. So that's like the big idea. Most of these concepts here, I think are pretty intuitive, but you're definitely going to need to know like how, yeah, like what factors influence entropy. I think they're pretty intuitive, right? Like gas molecules, there's a lot more um, chaotic than solids, right? Mixtures, right? Because there's multiple different kinds of it's not just like let's say you mix like water with NaCl versus water. Like water just has water. NaCl is now like adding another variable. So you increase the um I guess the differences or the complexity, which causes entropy to increase. Um Pressure and volume. This is like kind of similar, a little similar to like Le Chandelier's principles a little bit. It's similar to like the stuff we talked about with like pressure and volume, but right? Like we said with the Erlenmeyer flask, like you have a certain volume. If you increase the volume, you increase the amount of space that this gas molecule can move, right? And likewise, if you increase pressure, you decrease the volume, right? So you make it more confined. And then, yeah, whenever you're talking about entropy with reactions, you have to go with the side with the most amount of gaseous particles, or otherwise, like the side with the highest entropy state, right? So like instead of it being gaseous molecules, they could be like liquid and aqueous, and so you want to make sure you're aware of that. And then likewise, atom and molecule size, right? So entropy increases with molar mass, but entropy also increases with the like overall mass. So like the entropy of a 5 gram like carbon dioxide is less than the entropy of a 500 gram carbon dioxide, right? And that's because there's more atoms. Okay, so just be aware of these concepts because it's very important. So yeah, you want to make sure you're aware of this because he could ask any of these questions and you'd have to know what's going on. All right, so with this is pretty important. This is this is delta S system, delta S surrounding. So when I think of a system, think of like the reaction vessel. So like let's say we have an Erlenmeyer flask. like this. Okay. And this is the surrounding. In an endothermic process, what's happening is heat is being absorbed into the system, right? So heat is increasing. And so if heat's increasing in the system, the delta S for the system is going to be positive. But the surroundings is where the heat is coming from, right? So because the surroundings is providing that heat, the surroundings delta S is going to be negative because it's losing heat. Okay. And then likewise, in an exothermic process, the system itself, um, right, it's giving off heat, right, because it's losing heat into the surroundings. So the surroundings is going to be delta S positive, and then the delta S system is going to be negative because the exothermic, it's losing heat. So just try to think of it like that. So yeah, you want to make sure you're aware of those two concepts. And then here is a law of thermodynamics. Is there any questions before of like anything else before that? Alrighty. So we have three laws of thermodynamics. You should be kind of familiar with some of these, right? So the first law is that energy is constant, right? You can never create nor destroy energy. Um, yeah, the second law is that yeah, all spontaneous processes are accompanied by increase in entropy of the universe. So like entropy is always increasing essentially. Make sure you're aware of this formula because this formula is really important for this graph that we have or this chart. Um, yeah, like if you have a delta S of universe that's positive, that means that the process is going to be spontaneous. And you can memorize this chart if you'd like, but if you remember the formula, this chart is actually pretty easy. Um, if like let's say the both of these are negative, this process is not going to be spontaneous. You can never get a positive number of universe. If the surrounding is positive, you need to have the, or sorry, yeah, if the surroundings are positive, you need to have a surroundings that has a larger magnitude of delta S system in order for delta S universe to be positive. And then likewise, the other way is true, right? The other, if the system is positive and this is negative, you need to have this value be greater than this in order for the universe to be positive. So like you can memorize this chart, but if you understand the formula, then you're able to, make sure you get the answer right. I don't think that this formula would be on the test, but it's not that hard of a formula. I don't think it's gonna be on the reference table. But anyways, and then yeah, this is also important. The third law, right? A crystalline substance, at 0 degrees 0 Kelvin would be zero. Um, yeah, just make sure you're aware of that. And then yeah, we're gonna use products minus reactants to solve for delta S. And so you want to be aware of how to do this. He's going to give you guys definitely like a chart like this with delta S values and delta H values, and he might ask you to find delta G. And so it's your job to make sure you're choosing the right kind of compounds. He's annoying in that he will give you wrong compounds, right? So we don't have H2O gas, we don't have H2 gas in the overall reaction, but he's giving you these values, and that's like annoying. Additionally, entropy is always in joules for some reason, and so you need to convert that to kilojoules. So those are some things to keep in mind. Um, yeah, and then we got free energy. And yeah, don't worry, we're gonna do more questions as we finish 7 and 8. And yeah, we'll lock in. So yeah, this is the formula. Delta G is equal to delta H minus T delta S. Um, And so if you understand or memorize this formula, you're able to actually get this chart. If you think mathematically, this would be really helpful. So in order for a spontaneous reaction to occur, delta G needs to be negative. And so in order to have delta G be negative, delta H, like if in order for delta G to be negative at all temperatures, delta H needs to be negative and delta S needs to be positive. Because when you have a negative times a positive, you get a negative number. So this overall will be negative. Negative minus negative is negative, so delta G is always negative at every temperature. Now, let's say hypothetically, delta H is positive. If delta H is positive, we're going to need to have a temperature. In order for delta G to be negative, temperature needs to be a very high value. And this is because this component of the formula needs to have a greater magnitude than delta H positive. So that's why at endothermic processes with a high entropy, delta G is negative at high temperatures, or the like reactions spontaneous at high temperatures. Now, instead of this, let's say that this is positive, or let's say this is negative and this is negative, delta S. Now we're gonna need to have the temperature at low like temperatures, which is what we see here, because we want this to have a greater magnitude than this. And then likewise, if this is a negative and this is a positive, it's non-spontaneous. You're not going to see any sort of thing. So you can memorize this chart, but again, like if you know this formula, you can understand it and it'll help you like do what better on the questions and I guess have that like long-term memory for later when you take the MCATs. Okay? So yeah, your job is to make sure you are able to plug in these values and solve. One thing that's important is that delta S is in joules, so you want to convert that to kilojoules. And so delta G naught represents conditions under 1 atm and 25 degrees Celsius. 25 degrees Celsius in Kelvin would be 298.15 K because you add 273.15 K. And yeah, for this kind of question, you would do like something like Hess's law, where you would flip one of these, right? So in order to do diamond to graphite, it would be C diamond to C graphite. So you would flip the graphite equation, and it would be negative 397 plus 394, or negative 3. Um, and yeah, like so you might be given HF the naught and S naught values, and you can use those values to figure out delta G naught. So you'd have to do products minus reactants of delta H. Um, yeah, so like products minus reactants, right? And then delta S is going to be products minus reactants. Okay, and then yeah, now we're relating free energy in equilibrium, right? So when delta G is equal to 0, that means that the reaction's at equilibrium. And this makes sense, right? In the forward reaction, at one of the conditions of equilibrium is that the reverse reaction equals, or the rate of the reverse reaction equals the rate of the forward reaction. And so because the rates equal one another, that also means that nothing is like no reaction is being favored, which means delta G has to be 0. And so when we do this, we have this equation, which I think is on the reference table. Delta G is equal to delta G naught plus RT, natural log of Q. Um, and then yeah, at equilibrium, delta G is equal to 0. So you can figure out this equation, where you can figure out K. One thing to note is that the R value here is not the gas constant, or it is a gas constant, but it's 8.314 joules over Kelvin. Um, so yeah, keep in mind this value. It's in joules, so you want to convert that to kilojoules. And then yeah, you want to plug in accordingly. So yeah, like there's not a lot of concepts in this chapter, right? There's a lot of math. The concepts here would just be like the entropy changes and stuff like that. And also the equilibrium. But besides that, like most of the math is just kind of plugging and chugging and solving. So that's why this module is not like super conceptual, but of course the entropy is like the thing that would be conceptual, or like even like the solving for delta G naught, like is delta G not positive at a certain delta H or delta S value. You want to be able to be aware of this. This is like probably the biggest concept on this besides the entropy. All right, so that's kind of module 7. Does anyone have any questions about that? Okay. Um, yeah. Let me know. I can't see the chat. So if you're private messaging me anything, like I can't see it. So just let me know. Did someone say something? Okay. Alrighty. So we got electrochemistry. Okay. So this is kind of a review from last semester, but you want to be aware of all of these rules for like the oxidation states for things, right? Also be aware of oxidizing agent and reducing agent, because he has been like we've seen him ask questions about what is the oxidizing agent, what's the reducing agent. Be aware of oxidation and reduction, right? Oxidation is the loss of electrons, or you could also think of it as the production of electrons, and reduction is the gain of electrons or the like the use or consumption of electrons, right? Um, Oil rig is like a good little example, right? Oil rig, oxidation loss, reduction gain. And so here we have half reactions. And so I'm probably gonna re-go through over like probably go over like how I would solve these kind of questions. And so just to like start off, right? Whenever I write the oxidation reactions, I'm gonna just use like these like individual things that are changing. So after finding the oxidation states, I see that copper is becoming more positive and chloro or hydrogen is becoming more negative, right? That's why it's going from plus to zero, right? And so when I write this out, it's going to be Cu to Cu plus 2, H plus 2, H2. I'm ignoring Cl minus because Cl minus is, um, it doesn't change in the oxidation. And so I balance accordingly. And then I solve for the electrons, right? And so yeah, this is going to be oxidation. So oxidation, the electrons are lost, so that's why it's in the products. And the reduction, the electrons are gained. And so we see that they're equal to one another. And so then we can combine the reactions to get the net redox reaction. And we can see that it's balanced in mass and charge. And then we can see that yeah, like that's like kind of part of like how I would solve these kind of questions. Okay. Um, and so yeah, you want to make sure you're aware of how to balance it in acidic and basic mediums. I'm gonna just solve for a basic medium question because by solving for basic mediums, I'm essentially solving for acidic mediums as well. Um, and yeah, like I'm not gonna spend so much time on this because I have a YouTube video where I go over how I do this. So yeah, I'm gonna just spend some time. And yeah, please feel free to like shout out if you're confused about anything I'm doing or anything, because that's really important. This is your time, not my time. All right. So let's see. So when I see this question, I'm gonna first write the oxidation states. So Ag is 0, Zn is +2, Ag is +1, and oxygen is, or let me do a question that you guys probably are familiar with. Let's do this one. All right. So we see here oxygen is -2, so -6, right? So nitrogen has to be +5. I2 is 0. This here, I is +5. Oxygen is -2, so -6. +4, -4, right? -2. So I see here that iodine's becoming more positive and nitrogen's becoming more negative. So I'm going to write out N+5 yielding N+4, right? And then over here, I'm going to write I2 becoming I+5. And so I'm going to balance the mass accordingly, and I'm going to put the electrons accordingly. So what I can see here is because it's becoming more negative, the top reaction is reduction, the bottom reaction is oxidation. And so I'm going to put one electron here and to balance the electrons. And so I see here that there's +5, +4. So there has to be one electron to balance out the charge there. And likewise, there's a +10 on the right and plus or 0 on the left. So there needs to be +10 electrons on the right. And what we can see here is we need to multiply this by 10 to balance out um, the like electrons. We want the electrons lost equal to electrons gained. So after doing this, the overall redox reaction is 10n plus 5 plus I2 yields 2I plus 5 plus 10 and plus 4. And we can check if this is correct by balancing it by mass and charge. We see the mass and charge, the mass is balanced, and the charge on the left is 50, and the charge on the right is also 50. So this is redox, the redox reaction. So this is all good. And so after we do this, I'm going to put the coefficients into the overall reaction again. So we're going to go to 10 NO3 minus plus I2 yields 2 IO3 minus plus NO2. Um, yeah, everything's all good. And so now we need to ask ourselves which side has the least amount of oxygens. Um, so on the left side, we have 30 oxygen. On the right side, we have, oh, I'm supposed to put 10 here, 20, 26 oxygens. So we're going to have to put plus 4 H2O on the right. And after we add the oxygens, we need to balance it by hydrogens. So there's 8 on the right, and then there's no on the left. So we have to put 8 H plus on the left. And when we see this, this is how we balance an acidic medium. We can check the charge and the mass. The charge on the left is -2, on the charge on the right is -2, and everything else is balanced. And so this is how we would do it in an acidic medium. And then on a basic medium, we would have to add OH minus, an equivalent amount of OH minus to the protons on both sides. And so over there, we see that it's 8 H2O on the left, plus 10 NO3 minus, plus I2 yields 2 IO3 minus 10 NO2 plus 4 H2O, and then plus 8 OH minus, right? And so we see here that there's like terms, so we need to cancel that out. So the 4 waters are canceled out, leaving this to be 4 waters. And then the 8 HOH minus will be on the right side, like this. So it'll be like 8 OH minus. Okay? And so that's how I would solve for the basic medium. Okay, so I think I have like a bunch of, yeah, here's like the general rules, right? First, I find the oxidation state of the reactions, then I write the redox reaction, then I plug in the coefficients to the overall reaction, then I add water to the least amount, the side with the least amount of oxygens. Um, Here, let me just add something to number 2. I'm gonna say balance in mass and charge. That's important. And then yeah, add H plus on the to the side with the least amount of H plus, and then add an equivalent amount of OH minus to both sides. Okay, does anyone have any questions about how to balance things in basic and acidic mediums? I can't see the chat, so if you have questions, just shout it out. Don't be shy. Okie dokie. All right. Oh, my bad. Okay. So now we got galvanic cells. Okay. So galvanic cells are batteries. So there's galvanic cells, voltaic cells, and also electrochemical. They're all the same, they're all synonyms. And they all just represent batteries that convert chemical energy to electrical energy. And the big idea with these are batteries are spontaneous. So they have a negative delta G. Salt bridges, their job is to use ions and migrate them accordingly. So if we have an anode here and we have a cathode here, the salt bridge is going to produce or is going to give ions accordingly. And this is because the anode, you don't want the charge of the beaker to change, and you don't want the charge of the cathode to change. And so to reconcile this, the salt bridge adds ions accordingly. And so the anode is oxidizing. So this is becoming more positive because let's say hypothetically it's going from like Cu to Cu plus 2. It's becoming more positive. Whereas the cathode is becoming quote unquote more negative because it's becoming, let's say hypothetically, it's like Zn plus 2 to Zn, right? It's becoming more negative because it's losing the plus 2, right? And so in order to combat that, the Cl minus is going to go toward the anode part and the Na plus is going to go towards the cathode part. So the positive cations are going to go to the cathode and the negative cations are going to go to the anode. So that's like a little, um, I'm just kind of elaborating on what the salt bridge does. Um, and so, yeah, your job is you want to make sure you're aware of how to write out these like cell notation, right? So the left side is anodes and the right side is a cathode. And so you want to make sure you're aware of what these things mean and how these things could be like written. Um, yeah, it could be written like this with the like with a like random polyatomic ion, or it could just be written like um Cu plus 2, right? And then Ag plus Ag solid, right? So you want to make sure you're just aware of how it can be written. Um, Sometimes the electrodes don't even need to be in the reaction. They could just be simply catalysts. So like sometimes you see like platinum, and instead of it being like Cu, it could be like Cu plus to um, Cu plus 2, right? And likewise, Ag plus to let's say instead of the Ag plus, let's say zinc plus 2 to zinc plus 1, right? Let's say it's like palladium, right? So like these electrodes don't have to be in the overall half reactions, um, but it's just important that you're aware of that. And so yeah, so yeah, you want to make sure if you're given something like this, like an image, you might want to make sure you're aware of build. You want to make sure you're able to write the cell notation. I've never really seen Yusuf really use an image like this on the exam though. So like I feel like the better alternative would be like he just kind of writes things out in a paragraph and you would want to make sure you're aware of how to write the cell notation accordingly. The big idea with this is that the cell no like these cells need to have a positive like E cell, right? So these because these batteries are spontaneous, the voltage needs to be positive. I did not spell voltage right. Voltage needs to be positive. And so because of that, depending on the reduction potentials which are given in the reference sheets, you can determine what the E cell will be. And by extension, also what should be the cathode and what should be the anode. Because even if you're not given, let's say hypothetically on the exam, you're given like these different electrodes, right? And you don't know what's happening. Like you don't know if this is the anode or cathode. Like you don't know which direction it's going in. You don't know which one it is. And likewise, you don't know which one it is. If you look up the reduction potentials and you add them up accordingly, you can figure out which one um, should be the cathode and which one should be the anode because you need to have a voltage that's above 0, right? You need to have a positive voltage. And so, like, let's say the cathode reduction potential is like 0.77, and the anode reduction potential is negative 2.37. Or sorry, let's say the Mg to Mg plus 2 is negative 2.37, and the cathode's um, voltage is 0.77. If this was 0.77, right, and we plugged it in accordingly, we'd get a positive value, right? So that tells us that this has to be the cathode and this has to be the anode, right? But if we were to like flip the values, so instead of it being that, like let's say instead it was negative 2.37 minus 0.77, we would see that you get a negative 3.14, right? So the like equation also helps you to figure out which one's supposed to be the anode and cathode. But again, yeah, you're going to be given this whole chart on the reference table, so you want to make sure you're aware of that. Make sure you're aware of these like temperatures and things like that. Yeah, you don't need to know how the reduction potential, where it comes from or anything. Yeah, so you want to
I
make
have a question.
yeah, what's up?
Um, there was a question that I was confused on your practice test that was like on this, and because I thought that like whatever's on like the I don't know how to explain it. Like, can you go back to like the thing so I can like show you like for like cell notation,
Hmm.
like up a bit more. Yeah, yeah, like that, right? Is it always like for like the anode side that like the electrode is on the left side of like the overall equation and then the active ions on the cathode side are always on the left side of the equation or no?
Yes. Yeah.
Okay, because there was a on question 28, it like I don't know, it, like wasn't that or
We'll go over the question after we're
okay.
done with the module.
But it is always like electrode from the anode side plus the active ions from the cathode side and then it goes to the like the other two?
Yeah, so like the idea here, right? The electrodes are always on the outside, but you can kind of think of it like the like anode, it's like it's showing what's going to be like the reactant to product kind of. And then here it's also going to show like what's the reactant to product. Sometimes the electrodes aren't in the reaction, but generally speaking, like it's kind of demonstrating what's going from reactants to products in terms of like the overall like redox reaction. So like let's say the electrode was like Mg solid, um, going to like Mg plus two, right? This kind of tells you that the reactant here is Mg turning into Mg plus two, right? Whereas like here, let's say this is like Zn plus two to Zn um like solid, right? This is also kind of showing you like this is the reactant to product. So like Zn plus two yields Zn. And you have to know which where to put the electrons.
Okay, thank you. But that's what I thought, but then like the question like show you after. That was like
Yeah, yeah.
confusing. But thank you.
Yeah, no problem. Um, anyways, so yeah, so you want to make sure you're able to use these half reactions accordingly. Um, yeah, what's it called? And so yeah, the trick here is that the E cell is always positive, so you want to make that's how you can also determine the anode and cathode properly. So that's most of the units. This is now the concepts. So this is important concepts. There are specific relationships between K, delta G, and E cell. And you don't need to really like fully understand like like it's obviously better to understand everything, but if you memorize this as well, you'll be able to do well as well. So if delta G is negative for the forward reaction, what does that mean? That means that the E cell has to be positive. And that also means that the K value is greater than one. That means that the forward reaction has occurred a lot more, or there's more products than reactants, right? And so that's why delta, like K has to be greater than one for that forward reaction. If delta G is negative, or sorry, if delta G is positive, it means it's non-spontaneous, right? And so because it's non-spontaneous, we can also say that, yeah, the E cell has to be negative, because that's what non-spontaneous means. And it also shows that there's more reactants like at like equilibrium. And likewise, if delta G is zero, right, that means that K is literally at one. And it also shows that E cell is at zero as well. So make sure you're aware of these concepts because you could ask questions regarding these things. And that's pretty much module eight. So module eight and seven aren't like such a big kind of topic. Um, and so yeah, it's your job to make sure you're pretty like comfortable. I think the biggest kind of question you could see is definitely like the bouncing and redox reactions and definitely the cell notation. Like you're definitely going to see questions regarding those two things. And of course, like the cell potential and stuff too. With like thermodynamics, you're going to see delta G, like probably this stuff. You're definitely going to see like stuff regarding, you're probably going to see stuff regarding this stuff, maybe. You're probably going to see stuff regarding the entropies, right? Um, and you're going to probably see a question regarding what's it called? The where is it? This formula. Okay, but this is where like you guys know for a fact like what kind of questions are going to be asked. So make sure you guys are like pretty prepared for those kind of questions. But anyways, we're gonna go over some questions. So which question did you want to go over? So yeah,
28.
which practice exam?
Uh, um, on it's on your practice exam. It's I think it's one on the top right of your screen. I'm pretty
Like
sure.
the top
Not
of
that
this one?
one, not that one.
This one? Okay.
I think so, yeah.
Okie dokie. So 28. Oh yeah. So with this practice exam, by the way, I posted a YouTube video along with this practice exam where I go over each question as well. So just keep that in mind. All right. So 28. So we have this guy going to and this guy, right? So you can see that this is the anode and this is the cathode. All right. And yes, it has this platinum here, but this platinum has nothing to do with the overall reaction. And that's because we don't see any active ions coming from the platinum or anything like that. We just see chloride turning into chlorine and aluminum turning to aluminum like +3 ion. So like there's a couple of things you could do. I'm gonna go through it like how I would probably go about this question. So like Al um plus three, sorry, Al2, Al plus three, right, is the reaction we see on the anode side. And we see on the cathode side, it's Cl minus to Cl2. Okay. And so when I do this, right, you want to balance it by mass and you also want to balance it by charge. So on the anode side, you're losing electrons. So it's going to be 3 electrons here. And on the cathode side, you're gaining electrons. So it's going to be 2 electrons there. And so after that, we need to multiply this by 3, multiply this by 2. And so you're going to get a overall reaction of 2Al plus 6Cl minus yields um, Cl2 plus what's it called? I see what I made a mistake. Okay. So yeah, with this kind of question, it's a little bit weird, right? You want to make sure you have like an anode that's occurring, right? And a cathode. So like we know for a fact that aluminum to aluminum +3 has to be the anode. But here, right, obviously, like I was saying here, like it usually like reactants to products, but this is not the case here, right? The case here is that like if we did Cl minus to Cl2, this would need to have an electron on the product side in order for like the reaction to be balanced in terms of charge. But that's not what's happening, right? What's happening actually is that Cl2 is becoming Cl minus. And this is because um, this is the reduction side. This is the cathode. So we need to have electrons coming, um, like being gained accordingly. So yeah, so I was making a little mistake there. That's my bad. But yeah, aluminum +3 to 3 electrons. Did anyone was anyone gonna say something there?
So it's just like, um, whatever cancels out the electrons, so it's not like always reactants to products or
Yeah, I guess you could say that. I think the bigger idea is that like you know for a fact that this has to be the anode, and you know for a fact this has to be the cathode. So cathodes, you need to gain electrons. So the electrons need to be on the reactant side. And so um yeah, like I think the bigger picture is like knowing that like the electrons for a cathode need to be on the reactant side. And because of that, that's how you can figure out the like I guess like the half reaction for the cathode. Does that make sense to you?
No, it does now. It's just because he said in class, like reactants to products and then like reactants to
Um,
products. So that's why I thought like, you know, but thank
yeah,
you.
yeah, yeah. Yeah, no problem. So that's a good question. Yeah. So like I was saying, Cl2 plus two electrons, right? You multiply this by three, and multiply this by two, right? So 2Al plus two, 3Cl2 yields 2Al plus three plus 6Cl minus. All right. And that's choice D. Um, and so here's like the second way I would also go about this question, right? The second way is every sort of redox reaction or chemical reaction in general, it must be balanced by mass and charge. Okay. And so when we look at this question, we can see that A is not balanced by mass and charge. It's not balanced by charge. This left side has a charge of -2, the right side has a charge of +3. So A is completely wrong. B, it's also not balanced by the right charge properly. This is +3 and the right side is -2. So B is wrong. C is also um, C is actually balanced by mass and charge, but it's we'll get to C in a second. And E has the platinum, and that's also not balanced by mass and charge. So yeah, with C, we see here that yeah, like there is kind of a discrepancy because yeah, we know for a fact that aluminum has to be the anode here, but it being a product doesn't make any sense. And so that's why C is wrong. So like even if you weren't able to derive the overall formula, like you can kind of process of elimination like most of these question answer choices. Because you know for a fact that like a reaction needs to be balanced by mass and charge. So yeah. Um
Wait, Luke, can I ask a question?
yeah, what's up?
Oh, for this, he's never gonna trick us and like switch cathode and anode, right?
No, he would never do that. That's not
Okay,
fair.
okay,
That's
thank
not
you.
that's not nice. Yeah. He could theoretically though give you like he could give you this like as an anode and cathode, but it's not an actual like effective E cell. So like let's say instead of it being like aluminum +3 to whatever, right? Let's say instead he was like let's say it was like it's a little hard to say this. Platinum Cl minus to Cl2, right? Like kind of flipping the reaction. Um or yeah, it could be like Al +3 and then Al um as a solid, right? So like this is cell notation. So like for sure this is like the anode and for sure this is the cathode. But yeah, like would this be an effective E cell? It would not be an effective E cell. You would get a really bad E cell. So like he could give you a theoretical cell notation and then ask you like would this be a proper like would this reaction be spontaneous or whatever? And based off the E cell thing, you would say it's not because it's gonna have a negative. But yeah, it's always gonna be anode on the left and cathode on the right.
I have
Okay, Nina?
another question from
Yeah.
your on number 22. Like I get why it's A, but like kind of. But can you just explain like what would have to change in the question for the answer to be like C or D?
Okay. So this is based off the yeah, delta G is equal to delta H minus T delta S. And so this is exothermic, so this tells us delta H is negative, and delta S is, we have to look at the reaction to figure that out. So we see here that on the left side, there's no gas moles. On the right, there's 13 gas moles. So that means that the products, or this reaction has an overall positive delta S value. And so because it's positive and negative like that, we know that it has to be spontaneous at all temperatures because at any change in temperature, you're gonna have an overall negative delta G. Now, let's say they told you it was an endothermic process. If it was an endothermic process, you would need to have this would occur at D, a high temperature. And this is because temperature here, um, like if you increase temperature to a high number, you're going to get an overall magnitude of this value that's greater than the magnitude of delta H positive, which will make delta G negative because you have the minus T delta S. So that's why if it's endothermic, it would only be spontaneous at high temperatures. Now, instead of this, let's say you have delta S as negative. So let's say instead the reactants had gas molecules and the products had, um, like solids and liquids and whatever. Now we can only say that temperature has to, like, in order for the reaction to be spontaneous, it can only happen at low temperatures because the magnitude of this needs to be less than the magnitude of this. And so that's why like C is the answer choice if the products were like solids and liquids and the like reactants had gas. Does that make sense to you?
Yeah, thank you.
Yeah, no problem. Alrighty. Any other questions? Before I just start looking for questions for us to do. Okay. I want to pull up my practice final. I made some issues or mistakes. So let me erase some of this stuff. Wait, wait. Oop, oop, oop. Let's erase this. Work. Don't look at the answers. Close your eyes. Don't look. Oh my gosh, why is this taking so, wait, why is this so small? No, this is not good. Okay, you guys kind of already saw the answer choices, but it's okay. Don't look. Don't look. Thanks. But yeah, you guys could try to do questions 14 to 16. I'll give you guys like 6 minutes to try to do this, and then we'll go over it.
I know you said that Professor Yusuf was posting the answer key to his today, but is he still doing that?
I mean, that's what he said in the announcement. Like the information you
Oh,
have is not the same as mine.
oh, I didn't know
Um,
that it was on the announcement. Okay.
oh yeah, okay, okay. I if you email him, I'm sure he's gonna get on that.
Okay, thank you.
Yeah, no problem. I should have done this before. It's okay.
I have another question. It's like an
Yeah,
old
what's
one
up?
from like acids and bases. It asked about like increasing like acidity. You have to put it in like in order, and it was HOCl, HOBr, and HOI. What's like the rule for like you know?
Which one has the greatest electron density, right? So HOCl would be more electronegative than HOBr,
Mm.
and HOI is the least electron dense, right? So
Oh, okay.
yeah, it's like that. So
Okay, thank
HOCl
you.
would be the most acidic.
Okay.
Oh yeah, I'll give you guys a few more minutes to try to solve this question. These three questions. So yeah. Okay, dokie. So when I do this question, for the 14, first thing is to figure out what is being oxidized and what's being reduced. And in order to do that, we need to figure out the charges. So on the, this is supposed to be a negative, like value. This is also being negative. This is supposed to be negative. This is supposed to be negative too. So on the oxygens, it's -2. Let me make this bigger. Can this erase, please? Oh my gosh. Wait. Okay, so on the oxygen, it's -2. So that's supposed to be -10. Hydrogen has to be +1. And so in order for this to be a -1 charge, sulfur needs to be a +8. Oxygen is -2, so -4. And chlorine needs to be +3. Here, oxygen is -2, so -6. So chlorine needs to be +5. And sulfur is plus, or sorry, oxygen is -2, so -8. So this is +6. And so we see sulfur going from S+8 to S+6, and we see chlorine going from Cl+3 to Cl+5. So chlorine is becoming more positive, and sulfur is becoming more negative. And so the sulfur becoming more negative is reduction, and the chlorine becoming more positive is oxidation. So which is the reducing agent? It's the thing that's getting oxidized. So it's chlorite. So E. So that's the thing. So that's why E is the answer. Now we're asking it in acidic condition, so we need to balance it accordingly. So yeah, and they're asking how many water molecules is there. So let's do that. So what I do is I'll write out the individual thing that's happening. S+8 is turning to S+6, and chlorine's going from Cl+3 to Cl+5. Right, so this is oxidation, this is reduction. So this is gaining 2 electrons, this is losing 2 electrons. everything's balanced mass and charge, so we can combine accordingly. And so, yeah, everything is balanced by mass and charge. Let's see. Yep, 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 yep. Okay, so S plus 8 plus CL plus 3 yields CL plus 5 plus S plus 6. So we can add accordingly, plus 11 on both sides. And so we have nothing to actually change about the overall reaction. So it's going to be HSO5 minus plus ClO2 minus yields ClO3 minus plus SO4 minus 2. So now we need to figure out which side has the least amount of oxygens. The left side has 7 oxygens. The right side also has 7 oxygens. So we don't need to balance the oxygens. And now we need to balance the hydrogens. So the left side has one H and the right side has no H. That's why we add one H plus here. And so question, this is how we balance in an acidic medium. We can check it by checking the charge. The left side has a -2 charge. The right side also has a -2 charge. Everything else is balanced accordingly. And so how many water molecules is in this molecule? It'd be E. There's no water. And then when we add hydroxide in a basic thing, right? We add hydroxide to both sides accordingly. And we see that this becomes water. So this is now, oh no, I didn't mean to do that. Yeah, this turns into H2O, right? And then now we have hydroxide. And so the question is what's the coefficient of hydroxide? And it's a reactant, and it's going to be 1 electron, or with 1 coefficient. And so yeah, there's going to be kind of a question like this on your exam where it's kind of a chain question where you're going to be given an equation like this, and you're going to be asked like these kind of 3 questions. You know, it could be anything, but he's been prone to ask these kind of questions, so that's why I'm going over it. Okay. Okie dokie. Mm, 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 mm. Okay. With 17, I made a mistake here on my exam. It's not D. Um, yeah. I should have, what's it called? I should have erased some of these questions. Or I think these are like questions that are on the practice. But let me pull it up. So yeah, I'm gonna probably pull from questions from Professor Eustace's practice exam, just because I think that the practice exam that I gave you is more up to date. Because like I said, I believe, oh, he did put the answer key for the final exam. Oh, good. Uh, which question is this? This is 17. Where I don't know. I thought there was a question like this on the practice exam. Ah, yes. Look, do you guys see how this question is literally copied from my exam? Okay, do you see that? Because he reused the question. Okay, but anyways, I'm going to upload this and we're gonna do this practice exam to some extent. We're gonna do all the 7 and 8 stuff. Okay. All right. So I'll give you guys some time. Okay, let's try to do number 1. I'll give you guys like a minute to think about it and then solve for it. So I'll give you guys 1 minute for this question. All right. So with this question, it says which one will not run spontaneously. So this is a kind of a concept question. And this is based off the relationship between delta G and K and Q, or K like Q as well, to some extent. So anything that's not, or which of the following is true that will run spontaneously? So if this is running spontaneously, we would need to have a delta G value that's negative. And we would need to have a K value, or you need to have a Q value that's less than K. Because if you have a Q value that's less than K, that means there's more reactants than products. So that means the forward reaction would be favored. So that would be K is greater than Q. Um, and so the answer choice there would be choice B. Okay? All right. Let's see. You can do number 5 and we can do number 6. Try to do those two. Okay. These two questions weren't that bad, so I'm just gonna go over it now. So number 5, it says that we have an E cell that's 0.25 positive. So because of the relationship we know with E and delta G, we know that this will occur spontaneously. All right, so the concept there is the delta G relationship between E cell and um, K as well. Number 6, which of the following has the greatest decrease in entropy? Okay, and so when you see a decrease in entropy, you um yeah, like associate like gas turning to a solid. Um and yeah, so let's try to see that, right? Has no change in real entropy, right? It's going from solid to aqueous to solid to aqueous. B is 2 gas to 3 gas, so that's an increase in entropy, so that's wrong. We don't want that. C is a liquid turning into an oxygen gas, so that's actually an increase in entropy. So that's wrong. So B and C are wrong. D is going from gas to solid. So that's um, a pretty deep negative decrease. And then E is going from gas to 1 mole of gas. But I think the best answer would be D in this case. So the greatest decrease, yeah, is choice D. Okay. Oh yeah, so there is the HSO5 question that I just asked. Oh, that would have been nice if we just went over it on my. Okay, it is what it is. Let's see. Let's try to do question 11. I'll give you guys like some time to think about it, and then we'll do it accordingly. I'll give you a minute. I really want to get crumble this week. They have the cookie dough cookie. It sounds so good. I like cookie dough. All right. So for this question, it's a little bit of a red herring, right? We have temperature and states of matter, right? Liquid, nitrogen, and NaCl. And so even though the temperature increases, right, you have to recall, right, it's still a solid, right? And it's still, even though the temperature increase, it's still going to be a solid. And likewise, even though the temperature is here, it's still a liquid. And likewise, two is still a gas, right? And so the big idea is that gas, like the states of matter, like overtake like the temperature differences, right? You can only really compare temperatures if it's like all of them are gaseous, right? So in this case, it's simply going to be solid, liquid, gas. So one, three, one, and then two. Those are really bad eyes. Oh my goodness. So answer choice would be E in this case. Okay. We can do 14 to 15 as well. Let's do that. I'll give you guys a few minutes. Make sure you guys are looking at the reference table for 15. All right. Let's go over this. So, like we know, the left side is going to be the anode, and the right side is going to be cathode. And so, when it says which of the following species is oxidized, we want to make sure. Obviously, platinum is not part of the question, right? So we need to make sure we know. So the this part is Cu plus one and Cu plus two. So the thing that's being oxidized is the thing in the anode, and specifically Cu plus one is being oxidized into Cu plus two, like that. Okay. Um, and then yeah, the question is what's the standard cell potential? So if you go all the way to the reference table, um, we have this list here. And when you look here, we can figure out the reduction potentials. So this is a reduction potential for the anode, 0.16, that's there. And gold would be 150, right, for the cathode. So E cell is equal to um, cathode minus anode. And so you just plug in the values accordingly, right? So 1.50 minus 0.16, so you're gonna get 1.34 volts. And let's see if that's an answer choice. All right, and we see that E is the answer choice. Okay, so not so bad. Let's see if I can find a harder question. Let's see, where is anything? Mm-mm-mm. Mm. Okay, let's try 40. I'll give you guys a minute to think about it. Okay, but this is just simply the relationships between delta G, K, and E. And so we know A is wrong. You can never have a K value that's zero. Delta G, that's technically right. Yeah, that's delta G equaling zero is right for sure. D and E are definitely wrong. K can like needs to also equal one too. And so that's why I see the answer there. Okay. Um, alrighty. We can do, let's do this question. 43. I'll give you guys like 5 minutes to try to do this question. Take some time and then we'll go over it. Okay. I'm just gonna go over it. So we need to figure out the delta G naught in this question. And so you could see here how he gives you so many freaking values and you don't know what to use. So what I would suggest is to make sure you highlight what you need to use. So you need to use this value because we see it in the question. And we use this one too because we see it in the question. We use this one because we see it in the question. And we use HCl because we see it in the question. Okay, and that's all ones we need to use. We can't use that. We don't need to use the other ones. So now to determine delta G, we need first do products minus reactants. So products would be, let's do delta H first, right? So negative 1125.3 plus 10 times 92 or so 92.30. Make sure it's negative. Okay, minus reactants. So this is going to be negative 394.35 times 2. Let me make some space. So times 2 plus 5 H2O. So 285.83 times 5. All right, so let me solve for that. So that's going to be negative 1125.3 plus 10 times negative 92.30. Boom. Okay. So this one's going to be negative 2048.3. And then the other one's going to be negative 394.34 times 2. And negative plus, I should put this as negative 2. That's my fault. I should have done that. Negative 285.83 times 5. Okay. Just minus this is you. Delta H is positive. Okay. So I got minus negative 2217.83. And so I got a value of 169.53. Did anyone get this?
Mm-hmm.
Okay, sounds good. Good. So delta S naught is equal to, now we just do the other one, right? So this, it's 337.8 plus 10 times 186.19 minus 401.9 times 2, or I'll do that, plus 70 times 5. All right, so let's do that. 337.8 plus 10 times 186.19. 186.19. Okay, so I got 2199.7 minus 401.9 times 2 plus 70 times 5. This is 1153.8. So this minus this, I got 10045.9. And that's joules over mole Kelvin. Did you guys get that for S? Delta S?
I got 1053.
Oh, new 1053.
Wait, I'll do it again. I'll do it again. I think I
Wait,
messed
wait,
up.
maybe I messed up. let's see. This is right. This is right. This is right. Right. Let's see. Let me look at the answer key to make sure I'm following it right. Yeah, no, I think I did something wrong. That's my bad. Let's see. Let me hear. Try it again. 337.8 plus 10 times 26.9. Okay. Wait, what did I do wrong? Wait, what? Oh, I did something very small. Okay, I see what I did wrong. Oh, my bad, guys. Yeah, I got the same number. My bad. It was something with this. I put you see I put 186.19. It's 186.9. Yikes. Such a small little thing. I don't know why I did that. But yeah, that makes things better. All right, sorry about that. So yeah, joule over mole Kelvin. So we need to convert this to kilojoules. So 1.053 kJ per mole Kelvin. And so to find delta G naught, we have to just plug it into the formula. And so we can do that accordingly. So 169.53 kJ per mole minus, and so that temperature would be 298.15 Kelvin times delta S naught, which is 1.053 kJ, kJ per mole Kelvin. And yeah, so let's solve for that. So and plus or negative minus 298 times 1.0. All right, and I got a delta G naught value of negative 144.264 kilojoules per mole. That's right. Let's see. What? How did I get one? How did he get? Oh, he rounded. Wait, how did he get 1 point? That's really close. Why is it? It's pretty close. What did I do? Like I did some small thing wrong. Oh, brother, what is? Am I just? I feel like I'm like dyslexic. Oh my goodness. Oh my goodness. Sorry, guys. So this is supposed to be 1.6, 169.6. I'm making like such small little things there. Small little errors. Okay, everything looks good. All right, so I'm just gonna slightly modify this and then make this 144.4. Okay. All right, the process is there. I'm just like not reading the questions, the numbers right. So when you're on the exam, make sure you read the questions and the numbers right. And then here for B, right? Find the equilibrium constant. So we have delta G naught. We know what standard temperature is. So we can plug it into this formula. Delta G naught is equal to negative RT natural log of K. And so delta G naught is 144, negative 144.4 kilojoules per mole. I'm not going to put the val in units. Negative RT, negative R is 8.314, but it's going to be 0.008314 because we converted to kilojoules. Temperature is going to be 298.15 Kelvin. And then we have natural log of K. So let's divide those two things or these three things together. Um, so negative 144.4 divided by negative 0.8314 times 298.15. Okay. So I got a value of 58.25, blah, 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 right? Equals natural log of K. So we need to put everything to the E power. So to get K. Okay. So when I put everything to the E power, I found that K is equal to 1.99 times 10 to the 25th power. And this makes sense because delta G is negative. And that is correct. So does anyone have any questions regarding this? The only thing that was like taking up my time was the fact that I was making little mistakes here and there. But besides that, the process is there. Okay. Does anyone have any questions or comments or concerns?
I have a question. I remember him explaining this, but I kind of forgot. Why do we use a different value for R instead of the 0.08
Uh,
that we used to use before?
Yeah, so 0.08206, it doesn't have anything regarding like energy, right? So this is like 0.08206 ATM. Oh shoot. Um, ATM liter over mole calorie. I forgot the units. Oh no, I don't remember the units. But the whole thing is that there's no joules in this, right? That
Oh, okay.
8.314 is in joules per Kelvin.
Okay, okay. Thank you.
Yeah, so that's why we use that. Yeah, is there any other questions? Okay, so yeah, I think like the bottom line is 7 and 8 doesn't have like the most difficult kinds of concepts. It just has like some math, some tedious math that you have to do. Make sure you know the cell potential, stuff like that. It doesn't go super in depth with like a lot of the more complicated electrochemistry concepts, but um, yeah, it's a pretty, I feel like, surface level discussion about it. The big thing is probably the redox question. That's probably going to be three questions on your exam. So just make sure you're aware of how to do that properly. Make sure you can learn how to do it fast so that you can spend time on other questions. But yeah, next module or next time we do this, we'll be going over the practice exam. And yeah, okay. If you guys have any leftover questions, I'm here. But if not, I'm gonna stop the recording and yeah, have a good day.